Here's a really unique barn find. This is a National Schools hand-wired radio receiver from the 1950s. This was part of an electronics course way back when. And in order for you to get through that electronics course, you had to hand build this radio receiver from scratch. How well do you think the person did that put this thing together? Do you think it works? Well, in this video, we're going to find out. And if it doesn't work, well, we'll make it work so we can listen to it and see what it sounds like. Let's get started. I wonder how many of these radios still exist today. Probably not many, if any at all. The condition of this radio is surprisingly good considering the conditions that it has been in. You see the metal base on this tube is split and it's trying to come off, and the paint is missing on all these tubes. You can tell it's been in the weather, that's for sure. But the chassis itself is in surprisingly, good condition. Not much rust or anything like that. The thing that surprises me most is the dial glass. There's no cracks in it. It's held on by 2 screws. Now, if you look here, you can see the gap because the pointer's in here. If I just press on this just slightly, you can see it flexing. The glass itself, it's very surprising this hasn't cracked. And again, there's 2 holes drilled in the glass and it's held on by a screw and a bunch of nuts here. So very lucky that way. So pretty happy to get this in, this particular condition. So it is missing, a tube here, and the line cord is, pretty bad looking. Oh, I did find this. This is very neat. Look at this. National Schools brings you a new dimension in training for television radio electronics. Look at the radio. It's the same radio. So it shows him here doing his work, working on this thing here and figuring things out. And he's got his ghost instructor in the back here. You can see through him. I guess they're trying to portray that, you can do this at home and it's like having an instructor behind you looking over your shoulder kind of thing. Very neat. 1955. So neat to find the exact same radio that they used in their ad. So probably quite a few of these went out, but again, I wonder how many are still in existence. So in order for me to get this thing going, I'm going to need to find an audio transformer, because there is no audio transformer with this, and plug this into my isolation transformer and current limited variac supply. On the bottom side of the chassis here, you can see we've got quite a mixture of just all sorts of different components. So this has been worked on through time. So you can see we have wax capacitors here, and then we have ceramic discs here. A newer, more modern style of, carbon film style resistor here versus all the carbon composition. This is era specific, but this is a new replacement. So you can tell it's been worked on. It's got all sorts of different parts in it, So, whether this works or not will be interesting to find out. One thing that's nice about filter capacitors in a radio like this, because this radio has such low time on it, because chances are this was just used to assemble and, used as a test really, or, to build your experience in radios. Usually these don't have a lot of time, so that these capacitors will usually reform at least enough to do a test here. Would I trust them in the long term? No. But, for this test, they're probably going to be okay. If not, I'll bridge something in there for now just to patch the thing up so we can take a listen to it. So I'm going to need to find an audio transformer, and I'm also going to need to find a 35Z5, which is a rectifier tube, and I put that in there in order to get the series set to light up. I'm going to plug this into my isolation transformer and current limited variac supply. Again, this is considered a live chassis set. So that's the way that these were built way back when. Transformerless set, I guess you could say. Some of the chassis were isolated by capacitors, others weren't. Just depends on the design. But any time that an All-American 5 or All-American 6, some form of a transformerless set is worked on, an isolation transformer is a very good safety precaution to have. And of course, mine's current limited and on a variac as well. All right, I'll go get those parts and start putting things together, and I will be right back. Okay, I have a universal audio transformer out of the junk bin and a 35Z5 rectifier tube. I'll put this over here and I'll plug this in here. That should be okay. Now, if we look on the bottom of the chassis here, we can see there is no audio transformer. That's the reason, I needed to go get this. So all of these have a audio transformer. Now, when I say a transformerless set, I'm talking about the power transformer, not the audio transformer. All of these need an audio transformer to, convert the high impedance output of the vacuum tube to the low impedance speaker. So now, this here is the audio output tube, and this is the plate connection here. As you can see, this is running out to a wire, and then the other wire is running up over here to the filter can. So this was obviously powering some form of an external speaker that had the audio transformer attached to it. It's very common for them to do that back in the old days. So what I'll need to do is just attach these two wires to the primary of this audio transformer right here. So what I'll do, just to patch this in to test this out for now, is I'll just take some of the insulation off of these wires here and just twist it on to the primary leads of the audio transformer. So polarity not important. Again, just a test. That's that, and I'll grab the other one. Like so. And attach that to the primary side. I have a test speaker as well, and the test speaker will be attached to the secondary side here. So I'll just leave this like this, nothing is going to touch. And again, this is on a current limited supply, so if anything ever did go wrong, it'd be absolutely fine. So my external speaker is, I'll slide it into here, right there in the back. I did a video on this a while back as well. I restored that and painted it and did everything. It's been holding up quite nicely. Has a wrinkly type finish on it. Looks really good. So I'll move this over here. And let's see here. I'll show you the audio transformer, what's going on. Down like so. So hopefully there's enough wire here to create a connection. That there, this here. I'm getting my finger involved there. There we go. I'll just leave that like so off to the side. It should be fine. Now the line cord on this is pretty sketchy looking, so you can see here. Right. So it's definitely seen better days. But I'll be careful the way I plug that in. And again, it's current limited, so not too big of a deal. So I'll plug it in the isolation transformer over there. And let's see what happens. So this is the on-off switch. You can see the on-off switch on the back here. This is for the tuning. And this would be the band switch over here. So what I'll do is I'll move you up to the isolation transformer over here. And it's on current limit, and I've just got the Variac maxed, so I'll turn this on. And that glow that you see at the top there is normal. I'll get rid of some of the light here maybe, make that a little easier to see. And I'll turn the switch on, and I should see these brighten up and then come down again. And there's nothing happening. So either there is a burnt out filament or an open connection in the chassis. So what I'll do is reach over here and shut this off. And we'll take a look at the chassis, see what's going on here first. Just take a quick look, and if not, then it'll be to testing tubes. So I'll turn the turn this back up again, so get some brightness going on here. So octal tubes are very common to have pin 7 and 8 as the filaments, or pin 2 and 7 as the filaments. So whenever you're working on a set, if you just keep that in mind, it'll help you trace down filament, filament lead issues and things like that if you're looking at the filament circuit itself. So you can see here, again, the isolation transformer is shut off and both sides of the line are open, so I can poke around in here. If you're following along, you're doing so at your own risk. Know the dangers of working on transformerless sets and things like that. All right. So you can see the wires here run up to the switch. So it's these wires here. And it looks like they're using white and black as filament leads as well. So this is going to pin 7 and 8. And there we go, right here. And we can see down here, filament leads. There's a filament lead here, and there's another open filament lead right here. Well, that's rather easy, isn't it? So you can see, I'm just looking at the index, counting the pins. So you count clockwise. The index is right there. You can see that little index right there. So this is pin 1 and pin 2. And then it goes pin 3, 4, 5, 6, 7, and 8, right? So this would here, right next here would be 8 because they're 8 pin tubes. This would be 7, so this is the other filament. And obviously that's going to go to 2 because these are the same tubes. So you can see here that's should go in there. Why it's open, I have no idea. But looking at the rest of the wiring in here, you know, look at this, the way they've soldered this. That's not very well soldered to the chassis. And this thing has been so patched up through time. It's, yeah, it's definitely been through a lot of hands, most likely. Okay, I'm going to turn on my soldering iron, let that warm up, and I'll tack this, and I'll be right back. Okay, soldering iron warm. See if I can just tack this into place here. That looks okay. All right. Let's try that again. Let's back up like so. Is that out of the way? Wow, I can definitely smell that old resin from the solder, that old flux. It definitely, actually has a very pleasant smell to it. It's almost smells a little floral, like a perfumey. It's interesting smelling flux. So I've had rolls of solder with that stuff in it. Of course, you know, it's, you know, the old stuff has got, it's not very friendly, let's put it that way. But it definitely has a nice aroma to it, that's for sure. Okay, so I'm going to turn this off again. Make sure that's off. Turn this on. And let's see what happens. Here we go. Turn it on. Aha! That's what I want to see. Did you see that brighten up? So this is obviously going to start working now. I'll move down here. Let's see. At least the filaments will anyways. Turn off some of these lights again. Now this is running through the bulbs, right? So you can see the filament is starting to light up there in the rectifier tube, right in there, starting to glow orange. And I do hear a hum in the speaker. Oh, made an interesting noise there. So it's buzzing. I'll grab the speaker and hold it up to myself here so you can hear that. So that is okay. So now this is being current limited by the bulbs up here, as you can see on the top. It's being current limited by those right on the top. So what I'm going to do is I'm going to let this chassis sit for a while, maybe 15 or 20 minutes, and you know, to be very easy on the capacitors. So let them reform for a little bit. And if something does go wrong, if something was to short, those will just light up full brightness. So it protects everything. And that's what I'm going to do with this chassis here. I want these two filter cans, this one here and the one over here, to reform, of course, before I click the bypass switch and give this, you know, full AC line. That way we have a really good chance of possibly hearing something out of this. I'll let that happen again for about 20 minutes, I'll say. I'll let it sit for that. And I'll come back and flip the switch and let's experience what happens together. Okay, 20 minutes has passed. So what I'll do is I'll bridge this out and I'll make sure the volume is down. Bridge that out. Hum picked up just a little bit. The tubes will come to full brightness at this point. You can see that the cathode is nice and lit up in there. So, and it's humming quite a bit louder. You can hear that. Put that down. So, see what happens. I give it some volume. Oh, that's a good sound. That's the sound of reception. No antenna. No antenna. So what I'll do is I have my antenna up over here. See up there. So I will grab this and bring this down here. Put that down on the bottom. And I'll take a look. Okay, so yeah, this is going to be one side chassis. So I'll move you down here. Take a look down here. So that's what I was doing, is looking under the chassis. I'll clip this onto the chassis and attach this to here. Well, I'm hearing static, but no reception. Let's see what happens here. Maybe. Oh. Noisy. Let me move that down. Maybe it's very dirty. That sounded like short wave, so that might be short wave. Go back here. Oh, there we go.
And budget packages taking place. Order Johnny Fernandez.
Definitely it's receiving. That's a good thing. Wow. That control, of course, is not doing too well. So I wonder if it's this. Yeah, it is. Yeah, I can hear it. It just got more sensitive.
2000223. Like colors, I mean, you can almost take every shade.
The dangers of leaving children.
They had the best none.
Look at that. It's coming right to life. Wow. Not bad. So somebody obviously got this working. You know, it's just missing parts and pieces, right? And of course the tube and the filament line was open. So all the tubes in here are working. It's a thing that I find really funny, you know, whenever a radio like this, you know, it doesn't work. Everybody always blames it on the tubes. Almost all the time. You know, the tubes are always fine. It's always a problem in the circuitry on the bottom side, either a, you know, open resistor or a transformer or a bad capacitor or something like that. But usually the tubes are working. Very rarely do I find a faulty tube in a radio receiver. They do get weak over time, right? Because they do have a cathode in them and, you know, it's an emissive surface. So, you know, it does get weak over time, but a lot of these radios are so, I guess you could say, built so sparingly that you know, they'll run the tubes right into the ground and they'll still work, right? Very neat. So this is actually working. So it sounded like shortwave. That shortwave was receiving stuff. So this is receiving signals from all over the world right now. Pretty quiet down here. Now, of course, this all depends on band conditions as well, right? So different parts of the day, different parts of the bands will become active. It all depends on the conditions. I can see this thing being restored and being a real good performer. All over the world. That's the neat thing about shortwave is you can listen across the planet on just something as simple as this. No wires. That's the reason they called, back in the day, radios were called a wireless set, or they called them a wireless. It's because, no wires, no internet connection, no cable connection, no anything, just an outdoor wire, and you can listen across the planet on something like this. And that's what makes radio so incredibly neat, right? Standalone, completely separated from any other entity. It's basically the sender and the receiver. Nobody in the middle to stop anything, right? So that's why ham radio and all that is used for emergency services, because it's, point A to point B. Sometimes there's a repeater in the middle depending on the band you're on, but, point A to point B is the way to go, right? So yeah, that's seems to be working pretty good. Of course, it can only get better from here. So, a restoration on this thing down the road would definitely be it. For those of you that are interested in the SP600, the Hammarlund SP600 restoration, that's underway. Very, very big and time-consuming job. So I'm going to try and condense most of that into one video, and that's the reason it's going to take a little while to get that Hammarlund SP600 video done. I will most likely do the same thing with the Racal RA17C12 receiver, and the same thing with the R390 and whatever other receivers get thrown into the mix. So I'm going to try and condense them down into basically a single video, maybe an intro video and then the entire restoration, something like that, instead of dragging out in so many parts. So it is in progress. So all of you that are waiting for the Hammarlund SP600, it's a coming. It's just an amazing amount of work. And this will get thrown into the mix here down the road as well. I'd like to do this. This is a very bizarre design. In fact, what I'll do is I'll just shut this off and shut everything off, and I'll show you some very strange things that they've done in the circuitry of this National Schools radio. You can see on the top side of the chassis here, there's two 12SK7s right beside each other. There's a glass one and a metal one, right? Most likely just parts and pieces used that they've, people have found over time. Well, which is really strange here is, let's move this over here. What's really bizarre in this whole system is that, you have the standard mixer oscillator over here, and then it goes into an IF stage through a transformer here into an IF stage. Well, this is just basically a broad-tuned amplifier, just a wideband amplifier, this 12SK7, and it immediately goes from this one into this one. So the plate of this circuit here is just on a resistor, and it's capacitively coupled into this one. And then, of course, the output of this one goes through another IF transformer. So basically, this is just a wideband amplifier here. And I have a feeling the reason that they did this with this schooling is, of course, when a person back in the day ordered this stuff from a school and they're getting started into electronics, they really don't have all that much electronics or test equipment around, right? Basically, you tune it by listening on the air. You use things like the WWV to tune the shortwave bands, and then you just use radio stations to tune the actual broadcast band. Well, what they're doing is they're taking the IF section and giving it a broadband amplifier to really push the signal through, obviously to help the person that's build this with no test equipment. And that's the reason they have two 12SK7s, a broadband amplifier driving another stage here. Kind of an interesting setup, but that allows the person that's building this radio to use basic tools, screwdrivers and of course, what do you have when you're putting this together? Pliers, screwdrivers, a soldering iron. And then, of course, you're just going to use the radio stations and, everything like that to tune this up. They have, neat little tricks and, the tricks of the time to to tune something like this up. So kind of a neat setup. Very odd to have two 12 SK7s. One is a broadband amp driving another stage here. The rest of it is pretty universal. The rest of it is pretty much like a standard All-American 5. So they've got the, the pedigree converter, and then of course we have the two IF stages here, basically a broadband, then another IF stage which is tuned out here. And then just a rectifier, a detector, amplifier, and rectifier and audio output tube in this section here, and that's really all it is. So really neat setup. And again, of course, this is different. This National Schools radio is different than an All-American 5 or a standard All-American 6 style receiver, right? It's most would have the other 12 SK7 in front of this stage acting as an RF amplifier. But of course, in this, they've put it, two side by side, one just basically cramming signal into this one so that people could tune this with very limited equipment. Very, very neat design. So this will definitely get a restoration, and I will take you through the entire tuning process and everything like that. I don't have a schematic for this, but this is so simple. It really doesn't need a schematic or anything like that, but I'll take you through the entire process with me when I go about restoring this. So definitely stay tuned and, be subscribed and all of that great stuff. Lots of good stuff coming. I also have an electronics course where I teach both modern and antique electronics alike. So if you're interested in troubleshooting, repairing, diagnosing, and even circuitry design with both surface mount technology, the new stuff, and vacuum tube equipment, the old stuff, it's all there, and there is a lot of both for you to learn from. I even share my own personal designs there to help you learn in a faster way and to help you understand electronics, take it to that next level. It's definitely a great place to be. You're definitely going to want to check that out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. This electronics course is on Patreon, and I've been there for many, many years, and I've been teaching electronics for a very, very long time. So lots and lots of footage there for you to learn from, again, with many, many projects for you to build in your own spare time. There is no pressure whatsoever, and of course, when there is no pressure and the atmosphere is comfortable, that's when you learn. All right, I hope you enjoyed this video. If you are enjoying my videos, definitely subscribe and stay tuned. There'll be many more videos like this coming in the future where I will be doing electronic teardowns and circuitry design and alignments regarding RF and audio circuitry and all of that great stuff. Until next time, take care. It was a lot of fun, and I really enjoyed sharing this National Schools radio receiver with you. Until next time, take care. Bye for now.